Hey guys, today we're going to talk about finding the distance between 2 points in the coordinate plane. So we're going to take a look at this example. We have point A at -2, -1, and B at 10, 4. And the first thing we're going to want to do is draw a line connecting these 2 points, pretend that's straight. And the idea about distance is that the coordinate plane is based upon movement in the horizontal and vertical directions, the x and y directions. And if we were to draw a line horizontally in the x direction and vertically in the y direction, we would be forming a right triangle. And so it turns out if I want to know this distance between A and B, all I really have to do is use Pythagorean Theorem. Right? We know that if this point is at 10, 4, the x-coordinate of 10, and at A is at x equals -2, then I know that this entire length is 12, right, from 10 minus the -2. Likewise, up here I know my y is a coordinate of 4 at B, and y equals 4, and here I know my y is -1, which means that my distance is 5, the difference between 4 and -1. So it turns out in order to find D, all I need to do is use Pythagorean Theorem, and say that 5 squared plus 12 squared is going to equal D squared. And if we've been paying attention to our Pythagorean triples, we already know that D equals 13. And if you want, you can do the calculation to make sure. So it turns out the distance between A and B, which we would just write AB, is equal to 13 units. So let's take a look at another example. Okay, so here we've got 2 points again, C and D, that I want to find the distance between. And you notice here I've worded this a little differently. I just say find CD. You may also see something that says like find the length of segment CD. But either way, if I connect these 2 points, that segment can act like the hypotenuse of a right triangle, and you could draw it this way or above or below. Right? I'm making a rectangle here. It doesn't really matter which way. We can do it by counting, or we can do it almost like we were doing slope. The change in x, of course, is going to be 3 minus -5, which is 8. That's this distance here. Right? The change in y would be 2 minus -2. Actually, I've done that in the wrong order. I should be more careful. And it's -4. Of course, that doesn't matter when I'm calculating the distance formula. Why is that? Well, because when I square a negative number, it's going to become positive, right? So in this case, we get 64 plus 16 is equal to D squared, which means that D is equal to the square root of 80, which we can simplify as, hopefully you know this, but square root of 16 times square root of 5, which gives me 4 root 5. That's my distance between points C and D. Of course, I should mention, right, there's no such thing as a negative distance. So we should always get a positive value here, but again, we can kind of shortcut and say like just use 8 squared and 4 squared or something. But it is nice to make sure we're careful about the negatives for when we're calculating slope and things like that, where that does matter, even though it doesn't with distance. But let's take a look at a more general example. So the question now is, what if I have 2 points just randomly? I don't even know where they are. They don't have specific values, but I know that they consist of x and y values, the coordinates. How can I generalize what we're doing here? Right? Well, the first thing I'm doing each time is I'm connecting them with a line segment and forming a right triangle so I can do Pythagorean Theorem. Of course, I need to know what the lengths of these sides are. So the length of this horizontal side here is always the difference between the x-coordinates. And the length of the other side is the difference between the y-coordinates. So what we know, if that's D, is that D squared is equal to the difference in the x-coordinates squared plus the difference in the y-coordinates squared. Which means, of course, if I want the distance itself, I have to take the square root of all this. So this is what people would call the distance formula. And I can clean that up to make it look a little nicer. Okay, so here's our distance formula, but all we need to understand is all this fancy stuff with subscripts and exponents and all this, it looks very complicated. All it is Pythagorean theorem. So let's not overcomplicate this. All this really means is, right, one leg squared times the other leg, or excuse me, plus the other leg squared equals hypotenuse squared. So if I take the square root of both sides, I just get hypotenuse, and that's where this is coming from. So yes, we need to know the distance formula. I want to use it because it becomes more efficient. I don't want to always have to draw a triangle every time I want to find distance. But if we understand that that's what we're doing and where this comes from, we won't ever get confused and forget what it is. A lot of people forget, well, is this supposed to be a plus or minus? Is this supposed to be a plus or a minus? Well, we shouldn't be thinking in that way. We should be thinking of it as, well, how long is the length of this side and how long is the length of that side? So let's take a look at it at another example to make sure we've got this down. Okay, so this is a little bit more complicated just because we're being asked to find the perimeter of the triangle, meaning I'm not going to calculate distance formula one time. I need to calculate it 1, 2, 3 different times. So we'll just find one segment at a time. And so to find AB, obviously we can picture drawing this right triangle, but what I'd like for us to do with this example is see if we can get there a little quicker, right? I know that the length of the first leg is just going to be the distance between the x coordinates here, between 1 and 3, which is obviously 2 squared. The difference between 2 and 4, which is the y coordinates, is 2 squared. So AB needs to be the square root of 2 squared plus 2 squared, which is 8, which simplifies to 2 root 2. So let's go on to BC. With BC, now the difference between the x's between 3 and 7 is 4. The difference between 4 and 0 is 4. And if I take the square root of that, I get the square root of 16 plus another 16 is square root of 32, which simplifies to be 16 times 2. So I get 4 times the square root of 2 as my next length. And now let's take a look at AC. AC now, we are comparing x coordinates, and I'll go to black. 1 to 7 is a difference of 6 in the x coordinate direction. 2 to 0 is 2, and I take the square root, and this gives me the square root of 36 plus 4 is 40. I can rewrite that as square root of 4 times square root of 10, which gives me 2 root 10. So here are our 3 lengths. This is a good opportunity to talk about some radical properties. If I want to know the actual perimeter for this guy, my perimeter is going to be equal to 2 square root of 2 plus 4 square root of 2 plus 2 square root of 10. And so hopefully we know that if I have like radicals, I can combine them. Just picture this being like 2x plus 4x. But this is to something different. This radical is not the same, so maybe like a 2y. So I can combine these two to become 6 square root of 2. But I can do nothing about that 2 root 10. So this is our perimeter. And all we've done is distance formula, quote unquote, but really it's just Pythagorean theorem, but I'm just doing a little quicker. You can picture again that if I had right triangles everywhere here, how that would become. And that's basically the gist of it. So tomorrow in class we'll practice more distance formula and hopefully become experts. Thanks.